Good morning all of you. In today's session of class 10 physics, we are going to do one topic called critical angle and total internal reflection. So basically you see that if light is coming from a denser to a rarer medium, okay, suppose light is coming from a denser medium to a rarer medium, like over here the medium is denser, over here the medium is rarer. So if light is coming from a denser to a rarer medium, then the ray after refraction will bend away from the normal. That is something we know. Now what happens is that so basically the diagram may look like this. It may look like this is the angle of incidence and this is the angle of refraction. So whenever a ray of light goes from a denser to a rarer medium, the angle of incidence will be smaller and refraction will be bigger, and the diagram will look something like this. Now so suppose the angle of incidence is a certain value called IC. IC is called critical angle. Then the angle of refraction will be 90. So what exactly is critical angle? When a ray of light is going from a denser to a rarer medium, then the maximum angle of refraction that you can get in the rarer medium is 90. And when that angle happens, when the angle of refraction is 90, the corresponding angle of incidence is called critical angle. So critical angle is the angle of incidence in the rarer medium for which the angle of refraction in the denser medium is 90. That is the definition of critical angle. So basically you can look at the situation like this, that suppose if you start from normal incidence, you understand normal incidence, angle of incidence, angle of refraction, both will be 0. Then you increase the angle of incidence, suppose it is I, so angle of refraction is something R, and then angle of incidence, when it becomes critical angle of refraction is 90, right? So you are starting from this, and this one is the extreme case. So the refractive index of the denser medium is sin 90 by sin IC. So refractive index is sin 90 by sin IC. Refractive index of the denser medium with respect to the rarer medium will be sin 90 by sin IC, so 1 by sin IC. So refractive index will be 1 by sin critical angle, right? So what happens if the angle of incidence exceeds critical angle? Then what happens? So if the angle of incidence exceeds critical angle, okay, then there will be no refraction and there will be something called total internal reflection, right? So total internal reflection, as the name suggests, no part of the ray will refract, no part of the ray will refract, the entire ray will reflect and come back into the same medium. So that is why it is called total internal reflection. So this is the incident ray, this is a refracted ray, and no part of the incident ray will go to the refraction side, the entire ray will reflect and come back. And why is it called total internal reflection? Because it is 100% reflection, there is no part of the ray which is refractive. Okay, so these are the things. Now as usual I am giving you the homework. Okay, so now I am giving you the homework. So first homework question is, if angle of incidence is 30 degree, angle of refraction is 90 degree, then find the refractive index of the denser medium. This is homework question number 1. Then homework question number 2, if angle of incidence is 60 degree, angle of refraction is 90 degree, find refractive index of the denser medium. And homework question number 3, if angle of incidence is 45, angle of refraction is 90, find the refractive index of the denser medium. So total there are 3 questions based on this topic, critical angle and total internal reflection, and you may submit the homework anytime by 9 p.m. Thursday. Okay, I'll end the session. Bye all of you.